Question 4. We know that hydrocarbon has aliphatic and aromatic. Part 8. Name a naturally occurring source of aliphatic and aromatic hydrocarbon and outline how different hydrocarbon they separate. So the name of the source is crude oil. Crude oil has many different hydrocarbon. Okay, how we get the different hydrocarbon? So this hydrocarbon in the crude oil must undergo fractional distillation. By doing fractional distillation, those molecules that can separate according to their boiling point, one by one. So therefore, the method or the way that we separate them is fractional distillation. Part B. When alkanes are heated to high temperature in the absence of air. So absence of air means no combustion state. So it will not really form CO2H2O because no oxygen. And the molecules can break into a smaller molecules. Identify the type of reactions that are occurring. Okay, of course, is cracking. The larger molecule, when it forms smaller molecule under high pressure and high temperature, the process or the type we call cracking. Part 2. Write an equation which describe reactions between the heptane, when heptane is heated in the absence of air to form hexane, butane, and ethene. So you just try to put the heptane to form these three and balance it. Butane, hexane, and ethene. Part C. The equations shows that the combustions of the ethene form the CO2H2O. Calculate the volume in dm cube of CO2's form when 1 gram of ethene burns. Okay, so first you need to find the mole of ethene. 1 over its molar mass, you get 0.03571. Okay, this one and this CO2 is 1 to 2 mole ratio. That's why the mole of CO2 must be double. So now it's 0.07143. Okay, we need to use this mole of CO2, okay, times the molar volume, we get 1.71. Because it says that room temperature and pressure, you just use the molar volume. Okay, part D. So this table shows that the reactions between this chlorine and the alkane, and chlorine with the alkene. If the chlorine with alkane, it will undergo substitution. The type is free radical. If the chlorine reacts with alkene, it can undergo two processes. Either is add into the double bond, or is undergo substitution. Okay, and the substitution involve free radical. The addition is electrophile or electrophilic addition. Okay, part 1. During the first stage, in the substitution reaction, chlorines form free radical. Explain what means by free radical. Very easy. The species with unpaired electron. As long as the species has unpaired electron, so this we call free radical. Like chlorine. Chlorine radical has one unpaired electron and the rest is paired. Means it has three lone pair and one unpaired electron. Okay, so this one we call radical. because it has one unpaired electron. Part 2. Name and explain the type of bond breaking which occur to form chlorine free radical. Okay, so this is chlorine molecule. Chlorine molecules will undergo homolytic fission, means the electrons here, 2 electrons, okay, 1 electrons will move to the chlorine, another electrons will move to the other's chlorine to form 2 radicals. Okay, so therefore for part 2, the answer is Cl2 undergo homolytic fission. Okay, because it's asked the bond breaking. So which pair of electrons is shared out equally between the 2 atoms? Is shared out equally between the 2 atoms. Part 3. Name the stage of the reaction mechanism which occur when a methane molecule reacts with chlorine-free radical. When chlorine-free radical form and is react with others, especially like hydrocarbon, so we know that it must be propagation. Okay, part 4 is the equation for this propagation. Okay, complete the equations for the reactions which occur when methane reacts with chlorine-free radical. So when the chlorine-free radical approach the methane will undergo homolytic fission. Means 1 electron move to H from this hydrogen radical, 1 hydrogen move to the carbon from this methyl radical. And we know that the HCl must form. Means the hydrogen radical and the chlorine radicals now it can combine to form, share the electrons and form HCl. And the methyl radicals form. Of course, this methyl radical will go to next step, okay, try to reform the chlorine radicals again. Okay, part 5. Carbon atoms can form sigma and pi bonds within hydrocarbon. Explain the following statement with reference to sigma and pi. Okay, alkene reacts with electrophile, but alkane do not. Okay, this one you need to know what is nucleophile, what is electrophile. Nucleophile is the one that electron rich, it wants to donate a lone pair out. Electrophile is the one that electron deficient, it want to gain the electron. So in one reaction, it must have electrophiles and the nucleophiles together. Okay, so now for this, alkane only have the sigma bonds in the molecules, but the alkene has both sigma bond and pi bond. So we know that the electrophile, which is electron deficient, it will get attracted by the electrons in the pi bond here. So you get attracted, get closer, and this one of the electrons pair will move out and form bonding with the Cl. Means the C and Cl will form new bonding. Okay, it's just because of this why the alkene can undergo the electrophilic addition. Okay, because of this. Then it's from this intermediate, this carbocation, and of course attacked by the chloride from this dichloroethane. Right, so just remember, electrophile always attracted to electrons in the pi bond or electron rich place. Right, okay, so that's all for this question. Thank you.